Oh, okay, well, we are in the last week. All we got to do is get through a couple of lessons, and we're going to coast into Friday. So a couple of things. Friday is a half day. We get out at 12:40. It will be periods 1 through 4. So you will be the last class that I see on Friday before the break. One other thing I want to go ahead and make sure you're aware of. You remember a couple of weeks ago when we were supposed to go to the auditorium for the fentanyl presentation? Okay, so they're going to take care of that on Friday. So they're saying we're not going to have to go to the auditorium. They're going to send us a video link, and during your first period class, we'll watch the video. That means everybody will be, have what you need to, and you'll be good to go. Okay. What are those?
So is that like
Oh, cool. Cool, cool,
is
cool.
that
Supposed to be a baby. Okay. All right. But other than that, I mean, that's all we got going on this week. So let's go ahead and get started so we can finish. All right, so our goal today is to go ahead and talk about nonlinear systems. So we already, spent a unit talking about. We already spent some time talking about, systems of linear functions when two lines would intersect in a plane. Well, now we're going to look at some systems where what if it's linear and quadratic, or maybe even a quadratic and a quadratic. Now, on this first page here, this is just meant to be a review, like y equals negative 2x plus 8. That is in slope-intercept form. How would I graph this line? What do I start with? Okay, the y-intercept. So the y-intercept, here we go. So my y-intercept. Okay, so I'm going to go ahead and count from the origin. 1, 2, 3, 4, 5, 6, 7, positive 8. Okay, so I've got that taken care of. Now, my slope is the coefficient of x. Now, if it's not a fraction, I'm going to go ahead and put it over a fraction, because we always like to think of slope as rise over run. So from here, I'm going to go down 2 and then 1 unit to the right. Okay, so from this y-intercept of 8, down 2, 1 to the right, down 2, 1 to the right. And you can do this as many times as you like, but you only need 2 points to make a line. Okay. Now for this other one here, this is standard form. 4x minus 5y is equal to 20. So let's go ahead and rewrite it. First thing I'm going to do is freeze this negative 5y term, because I want to go ahead and get y equals. So every other term I'm going to move. So this negative 5y is going to equal a negative 4x plus 20. So all I did was subtract the 4x over, and now I got to do what? Divide through by 5. Oh, negative 5, yes. There we go. Almost forgot that negative. So y equals, okay, so we got 4/5 x, and that would be minus 4. 20 divided by negative 5. Okay, so any questions about how I put it in slope-intercept form? Okay, well, now we're going to take the y-intercept, which is negative 4, 1, 2, 3. There's negative 4 right there. Go ahead and make that a bigger dot this time. Now, my slope is 4/5. So what 2 directions am I moving from that point? Up 4, 5 to the right. So let's see, 1, 2, 3, 4 up. Okay, 1, 2, 3, 4, 5 to the right. So let me put a dot there. Oh no, we're going to be skipping some problems. But I mean, if you want to do every problem, I'm looking out for you folks, because I know you're about to have almost 2.5 weeks of vacation. Surely a day or two in, you're going to be thinking, I got to do some math. It's got to happen, right? Exactly. Now, I can also show you how to plot this line using the intercepts. Would anybody like me to show you?
what?
Using the x and the y intercepts.
No.
Are we sure?
Yeah.
Okay, moving on. Then we want to go ahead and remember some forms of a quadratic. We have standard form, ax squared plus bx plus c. Okay, now remember, in axis of symmetry, it was a little expression that we used a lot. Okay, the opposite of b divided by 2a. So this not only finds you the axis of symmetry, but it also gives you the x value of your vertex. Okay, so remember, your vertex was going to be found the opposite of b over 2a, but then f of the opposite of b over 2a. When we found that value, we were going to plug it back in the function. Okay, so in this case here, we've got a, there's b, and there's c. So let's see here. What's the opposite of 12? Negative 12 over 2 times a, so this would be 2 times 2. You're close. Negative 3. So I know my vertex, and remember, we always put the vertex right there in the middle of our table. In this case, it's highlighted for you, or shaded, I should say. So we're going to go ahead and put negative 3. Now, where would I put that negative 3 to find the y? Yeah, we go ahead and plug it back in. So f of negative 3, this is going to be 2x squared. So that's 2 times negative 3 squared plus 12x. Okay, so plus 12 times negative 3. And then we have a plus 14. All right, so let's see what we got here. I need a negative 3 squared. Ooh. So that's a positive 9. Now we're going to double that, so that's 18. Now 12 times negative 3, that's minus 36 plus 14. Okay, so what's 18 minus 36? Negative 18. And then plus 14. So we should be getting a negative 4. Now remember, your order of operations, once you get it down to nothing but adding and subtracting, you go from left to right. So the 18 minus 36 gave me the negative 18. Then I added on the 14. That's where I got the negative 4. Okay. Now, I didn't show you this before, but I want to go ahead and show you a really fast way to go ahead and work with these functions if you need to evaluate at a given x. This is going to be really cool. Everybody got a calculator? Okay, go ahead and turn that on. And let me show you. So you see this right here, 2x squared plus 12x plus 14? We're going to store that in the calculator. Let me show you what I mean. So go to your scratch pad, and let's just type in the function. So 2x squared plus 12x plus 14. Okay, I'm just going to type it in exactly as I see it. Okay. Now, in order to store it in the calculator, we're going to hit 2 buttons. I'm going to hit the blue control button. So I'm going to hit control. And then I'm going to hit this VAR button right here above 9. So control variable, and you'll know you've done it right because there's going to be a little arrow after that. Control and then variable. VAR. And then it gives me this arrow. Now, whatever I type after the arrow, the calculator will always know this function as that. So let's call it f of x. Put in f parentheses, don't forget your parentheses, x. F is down at the bottom. It's in the top row of your keyboard. Now, as soon as I go ahead and push enter, it's going to say done. Okay. Now, here's what's really cool about this. Like, what was the x value we had for this one? It was negative 3. Well, now that it remembers, it's going to know f of x as this quadratic here. If I go ahead and type in f of, and then I put negative 3, it will automatically calculate that for you. Okay. All right. Oh, you're talking about the rest of the table? Now, remember, are you okay? Now, if you want to bring up the table of values, yeah, you can go ahead and hit Control T. That was another thing that we did. But remember, when we were coming off the vertex here, we got this is negative 4. Remember, we just did increments of 1 in either direction. So we could go ahead and say this is negative 4, negative 5, negative 2, negative 1. Remember, we're just playing off that x value that we got there. Now, you can look it up using the table if you want to go ahead and graph this, or you can go ahead and use this little trick right here. So if I were to plug negative 5 into this function, what should I get? 4? What about negative 4? Yeah, and let me show you. I'm going to come back over here to my calculator. So f down here at the bottom, parentheses 4, or excuse me, I should say negative 4. So I'm getting negative 2. So besides the control T where you can bring up the table, you've also got this now. You can store the function in your calculator. And then you can double check me on this, but if you plug in negative 2, you get negative 2, and negative 1, you get 4. Okay, and then we go ahead and graph it. So let's see here. So negative 3, negative 4. The vertex would be right here. Negative 4, negative 2. Okay, negative 5, 1, 2, 3, 4. Then we got negative 2, negative 2. And then we got negative 1, 4. Okay, so we can see those 5 points are creating a parabola. Whoop, just like that. And let's try this one over here. But this isn't standard form. This is what? This is vertex form. Now, the axis of symmetry here was simply x equals h. There's nothing to calculate because you already know what the vertex is. Remember, this is your h. This is your k. What was the only one we had to change the sign for? The one on the inside. Because remember, when you're looking at it from a transformations point of view, we always take the opposite direction. So because it says x minus 4, this would be shifted 4 units to the right. Would it be going up or down 3? It would go down 3. And what's the negative going to do? Flip it. What do we call that in math? Reflection. It's going to reflect it. Do you have your badge? You went like that. So the vertex should be at a positive 4, negative 3. So 1, 2, 3, 4. There's the vertex right there. Okay. All right. And then we can go ahead and plug in some other values. 2, 3, and then we got 5, 6. We're just going off the x value that I have here. Now, what would you like me to do to finish filling out the table? Do you actually want me to graph it and pull up the table? Or do you want me to use that storage feature we now have? What's that? Control T? Okay. So negative x minus 4 squared minus 3. So let's come on over here. So I'm going to go to my graph screen. So it was negative parentheses x minus 4 squared minus 3. I did. There we go. So I've got my function in there. Let's go ahead and push enter. I see my graph. Control T brings up the table. Okay. All right. And then we can scroll through and see that we are correct. 4 did give me a y value of negative 3. And let's go ahead and fill in the rest of these. All right, so 2 is a negative 7. 3 is a negative 4. 5 gives me negative 4. And 6 gives me negative 7. Now, remember, one of the things that we spent a lot of time on, back, was it the beginning of this 9 weeks? I think it was. Okay. If you set up your table in this way, you're going to be able to see the symmetry. So remember, even in the table, you only have to figure out half of it because you already know the other half. Okay. All right. Let's see what this looks like. All right. So 2, negative 7. 1, 2, 3, 4, 5, 6. There's negative 7 right there. 3, negative 4. Okay, then I got 5, negative 4, and right there. Okay, so those are a little off, but that's good. All right. So we remember quadratics and linear functions. Okay. Now I'm actually thinking these here. Okay, solving a system graphically, it's really good, depending on how accurate your graph is. So I'll go ahead and work one of these graphically if anybody wants me to. If not, I'm going to focus on just doing this algebraically, which is the better way. It's going to give you the exact answer. But does anybody want me to do any of these graphical systems? If you'd like, I could show you in the calculator and how to find the intersection. You want me to do that? Let's do it that way. Let's do it that way. Okay, so let's try this first one. And it doesn't matter if it's two quadratics or if it's a linear quadratic. Okay, so let's type in this first one here. X squared plus 2x minus 7. So I'm going to come on back over here, document B. Okay, so we got x squared plus 2x, what was it, minus 7? Okay, so I'm going to go ahead and graph the first one. Okay, so there's my first graph. If we were to do it by hand, we would get the same thing. Now the other one, negative x squared minus 2x minus 1. So I'm going to hit tab and type it in. Negative x squared minus 2x minus 1. Okay, so I'm going to type in the other one. Now the solution to the system is where these graphs touch, where they intersect. So this point right here and this point right here. So to find them, okay, first off, has everybody got the two graphs? Does anybody need help? I'm going to hit menu. Okay, we're going to analyze the graph. I'm looking for the what? Intersection. And remember, we've seen this before. As soon as I do this, it's going to give me this vertical line, and it says lower bound. So let's say I want to find this one first on the left. Where would I put the line? What does lower bound mean? There you go. It means just to the left of what I'm looking for. I'm going to push enter. When it says upper bound, sweep it to the right. So see, there's my first solution. Okay. I'm looking for every ordered pair that makes both equations true at the same time. Okay. Now let's find this one on the right. What were the keystrokes again? Menu. Analyze graph. Intersection. Okay, so lower bound is left, upper bound is right. There you go. So it doesn't matter if it's two quadratics, linear quadratic. Those are your two answers. -3, -4, and 1, -4. Okay. In fact, I'll go ahead and just write those down. Yeah. So -3, -4, and then what was it? 1, -4? Would anybody like me to go ahead and plug one of those points in to show that it's going to work for them? Okay. All right. Did anybody want me to actually graph any of these? Okay. All right. Well, let's go ahead and work the same problem, but let's use substitution. We're going to do this algebraically. So we already know our answers should be a -3, -4, and a 1, -4. See, this is the same problem that we just solved graphically. So I just want you to see that another strategy is still going to get you what your answer is. Okay. So you'll notice both of these equations, they both equal what? They both equal y. So if they both equal y, I can set them equal to each other. I can say the first one, x squared plus 2x minus 7. I wrote a 2. That was weird. Equals the other one, -x squared minus 2x minus 1. They both equal y, so they equal one another. So I just created one equation. Let's combine like terms. Let's say if I were to go ahead and add the x squared from the right over to the left. Okay. Those are going to cancel. How many x squareds do I have? I've now got 2. 2x squared. Well, let's do it with the rest of them. So if I add the 2x, I'm going to have plus 4x. And if I add the 1, this is going to be minus 6 is equal to 0. Now, all I'm looking for are the values of x that are going to make this true. This is just what we did before. We could use the quadratic formula. We could go ahead and use factoring, or I could even use what? What's the only one I haven't mentioned? Completing the square. Okay. Now, before we do any of those, this one's kind of special. Anybody notice it? Two, 4, and 6, all of your numbers have a common factor. So we could actually simplify this if we wanted to. Let's just divide through by 2. So that's going to be x squared plus 2x minus 3 is equal to 0.
So we positive 6 will be turning this over.
X squared minus 2x minus 1. Oh, that's a negative x squared.
That's what.
Mhm. And that would be x squared plus 2x minus 7.
I'm just combining this terms over here.
Yeah, now if you move that over there.
That will turn to negative 6. If you turn over there, that will be turning to positive 6.
Oh, you moved it to another side. See, so if you go ahead and change the sign of 1, then your signs that you now have on the other two, those are correct. Like this equation here, this is equivalent to like what you did. I could have 0 equals negative x squared minus 2x plus 3. I can move everything to the other side. Basically, that's what you did. That's why that 1 has a different sign of that. Okay. Now, while we could do any of those, let's go ahead and factor because that's going to be the easiest one. What are 2 numbers that'll multiply to give me negative 3 but add to give me 2? Now 3 is prime, so the only factors are 1 and 3, but which one has to be negative? Would have to be 1. Okay. And that's great that I was able to factor it, but how does that help me find my solutions? What do I do with each of those groups? Set them equal to 0. So if x plus 3 is equal to 0, x equals negative 3. See, that's the x value for one of those solutions I'd gotten. If x minus 1 is equal to 0, x equals 1. See, that's where the other one came from. Well, where do you think I'm going to get the negative 4s? There you go. If I were to take these 2 values of x that I got, if I plugged them in, I should be getting negative 4 for each one. So see, I got the exact same answers that we did when we used the calculator. Okay. How are we doing? Anybody lost? Anybody having a hard time? Okay. I'll tell you what, let's do one more and we'll be done. Okay. So let's do this one because this one's a linear and it's also a quadratic. The one on the left. So x plus y equals 2, and then y equals x squared minus 4. Okay. So we want to use substitution. Well, you'll notice the second equation is already y equals, so why don't I take that and I substitute it into the other equation. So instead of x plus y, I'm going to have x plus x squared minus 4 equals 2. I'm sorry. Did I say plus or minus 4? I don't know. I'm not even listening to myself. I'm thinking about Friday. I'm ready to go. My mind has already left. My body just got to catch up with it. Okay. So is everybody okay with what I did? Okay. Well, let's go ahead and rearrange this. So now we have x squared plus x. Well, if I subtract the 2 over, that'll be a minus 6. Okay. Now, we can factor this one, or would you like to try another strategy? You just want to factor it? Okay. Well, what 2 numbers will multiply to give me negative 6, but then also add to give me this positive 1 right here? Okay, so it's got to be 3, and it's got to be 2, but negative 2. There we go. Everybody okay? All right. And what do I do again? I always forget. Yeah. So if x plus 3 is equal to 0, x equals negative 3. If x minus 2 is equal to 0, x equals 2. Now, because we're looking at a system of equations, because I got 2 answers, that means there's 2 points of intersection if I were to graph them. So one answer would be -3 and then something. The other one would be 2 and then something. Well, how do I find those y values? Plug them back in. And here's my question. Does it matter which one I plug them into? No. What do you want? You want me to plug it into the linear or the quadratic? The linear? Okay. So the linear says x plus y is equal to 2. Let's plug in the first one. So a -3 plus y is equal to 2. Well, that tells me y would equal 5. So the first point of intersection would be -3, 5. Okay. Now we'll do the same thing for the other one. So x plus y is equal to 2. So in this case, 2 plus y is equal to 2. So what's my other one? 0. So there we go. Would anybody like me to graph those and show that this is exactly what we're going to get? Trust me? Okay. All right. Well, if everybody's okay, we're done. Told you it was going to be easy.